All right, so let's do this this section. So there's some more domain and range stuff in this section, but so most of this is pretty straightforward, but when you start getting domain and range problems, those are always a little bit sneaky. But this one's not too bad. It's just anything. It's just conceptually there's a thing going on. So it's just you can add, subtract, multiply, and divide numbers, and then you do the same thing with functions. So so f plus g. So let's say you're given two functions f and g. Well, f plus g is this brand new function. Conceptually, it's just this plus operation where we're not just adding 1 and 3, we're adding two functions, like the square root function and this squared function. Addition just means, just by definition, this means you apply the function f to x, and then you add. So f plus g is just another function. What does it do to a number? Well, you take f of that number, and then you also take g of that number, and you add the two results. And it's the same for any operation. It's like conceptually, this is new, but sort of it's pretty intuitive. It's just you it's this third one here. If they write absolutely nothing at all in between, then that's like multiplication. Like if you have x, y, that's x times y. Fg is understood to mean. Usually I see it written with the times. Fg is a brand new function, and then what does that do to x? It's by definition, it means that you just take f and then you multiply that by g of x. So you know, f times g of x is just f of x times g of x, and then f divided by g. Like sometimes they write it horizontally, they might write it vertically. It's just the same division symbol, however you write it. F divided by g of x is by definition f of x divided by g of x. So not super duper exciting. That's kind of, it is what it looks like. There's no tricks here, but the domain problems are a little bit tricky. And there's a hint that I wrote down on the homework problems, and we'll see that in detail right now. So there's an example that I think was number 23 in the book. So book number 23, I think it was f of x equals square root of x plus 3, g of x equals square root of x minus 3. Let's take plus minus times divided by. I forget exactly which ones I did. Let's just do it. Let's do it. Everything I can possibly think of here. So let's. So I might be changing the problem slightly, but I want to find the function, the result when I put these two functions together, and the domain for these different combinations. plus g, we have f minus g, we have fg, we have f over g, and then g over f. Let's see if that's anything different. So these, so there's a bit to think about here. So let's do a little bit of review here. Let's look at f and g separately first. So this might be of interest. Well, the function f, we have minus 3, which is okay, we're taking the square root of x plus 3, so the inside of a square root 0 is okay. If x is like -2, then we get square root of a positive number, so these are okay, but these are not okay. Like, we cannot take the square root of -1. Like, if x is -4, we're taking the square root of -1, so that's not okay. So it's kind of, we need to understand the domain of f. We also need to understand the domain of g. The domain of g is, it's the same thing, but it kind of starts at +3. So all the way up to so because g of x is, we try to take the square root of x minus 3, and we want a real number to go in, and we want a real number to come out. Well, if you take the square root of 0 by plugging in x equals 3, square root of 3 minus 3 is the square root of 0, which is 0, which is totally fine. But if you try to plug in x equals, if x is only 2, then you're taking the square root of -1. So -2, or x equals 2 is not okay. So let's see what this has to do with problem letter A. So here we get both of these issues in the same problem. So f plus g of x is f of x plus g of x equals the square root of x plus 3 plus the square root of x minus 3. Well, let's see. So what numbers are okay? Well, it looks like 3 and -3 are both numbers that are sort of interesting, but -3 is no good for this one. -3 is good for this one, but that's only half of the expression. You can't fully evaluate everything until x is at least 3. So that's what the function is equal to. But then the domain, well, here's where we have, so kind of like, here are all the boundary points where something interesting happens. This one, you plug in a -4, it's no good. You plug in -3, g of x fails to exist. So you can't do that. You can't do this one either. So some kind of, square root of x minus 3 does not exist here. If you try to plug in a 0, you're trying to take the square root of -3, which does not give you a real number. But if x is exactly 3, you're taking square root of 6 plus square root of 0, which is just the square root of 6. That's totally fine. So right on this boundary point, we're okay. If x is 4, then this is a square root of 7. That's fine. This is square root of 1. That's also fine. You plug in 4, it's totally fine. Just where are all the places that we might have problems? You look at both of them individually, and then you look at the entire expression, and everything works out okay as soon as x is bigger than or equal to 3. So domain starts at 3, goes all the way to infinity. All right, so for part B, part B is almost exactly the same. So this was part A. If you want a solution to part B, most of it is exactly the same. Not a whole lot of it is different. So so you might want to pause it. This is answer to part A if you want to look at it some more. Okay, so then part B. Now we're doing part B. It's almost exactly the same, this little step here is, so what happens? Let's walk through it again. F minus g of x is, by definition, you take f of x and then you subtract g of x and then take that full result here, and you get this difference, square root of x plus 3 minus square root of x minus 3. So what happens? None of these exist for x is less than minus 3. When x is equal to exactly minus 3, the first one's okay, but the second one is not. So you can't get an actual number out of it. When x is like in here, like if x is 2 or x is 0 or negative 2, you're taking square roots of negative numbers, but suddenly it's okay when x is exactly 3, and it continues to be okay when x is larger than 3, such as 4, 5, 100. So for the subtraction, you get exactly the same domain. Just the function itself is this expression here. So that's part B. So you can pause that. Mostly the same, so you can go kind of fast. Part C is also D and E are going to get interesting, though. That's going to be another story. But part C is also kind of mostly the same, except it's with times. All right, so what's interesting about this one here is that you might be tempted to simplify some things. So the correct thing to do is you don't do any algebra whatsoever. You just take that expression and you just leave it as it is, and you don't try to combine square roots. So this is kind of a warning. This is kind of a trap. It's almost the same, but the domains are not the same, and then it can lead to danger situations. So when there's this warning on the homework problem that says find the domain before you simplify anything, this is the kind of thing I'm talking about. Well, there are identities that say you can multiply 2 square roots in a certain way, but there's a kind of some conditions apply. So what I mean by that is this is the disclaimer right here. This identity only works for positive or 2 non-negative numbers is the only time that you can do this. Otherwise, bad things can happen. So if you don't know whether or not the 2 expressions are positive, then these 2 expressions are sort of the same, except this one might have a bigger domain. So if A and B are both negative, the right-hand side is well-defined, but the left-hand side, ooh, I don't know about that. I right now I only believe in real numbers. I don't believe in imaginary numbers. So this makes sense and it means something. if A and B are both negative, but if A and B are both negative, the left-hand side is undefined. So so what can happen is you get, if you combine them together, then suddenly you have this quadratic on the inside, and then there's this weird, like, what's the domain of the square root of a parabola and all that, and you have to look at all these different cases, and it's like, well, actually, you're not allowed to combine them in the first place. This identity, some conditions apply. And well, first, maybe let's look at domain, and then once we've established that the two numbers are positive, well, some conditions apply here. If x is bigger than or equal to 3, then we're in this domain where both expressions are square roots of non-negative numbers, and then we can take the square root of, then we can, square root of a times square root of b is equal to square root of a times b, and then that's kind of okay. And then you can write this however you want. You can write this as square root of x squared minus 9. Yeah, you can do all sorts of things, but only this is really kind of a fine print. It's sort of a subtle point, but it's mathematically, it's like if you try to write a computer program that does something and your computer keeps crashing because you told it to do something, and then it's like, no, I can't do this step because that's not a real number. And what you did is you didn't see this because you just sort of skipped over it because it's like blah, 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 I combine the square roots. Well, that's the trap right here. So if your computer is dividing by 0 or crashing on you because it's trying to do some illegal operation, in this case a mathematical operation, well, this is the kind of thing that it's really hard for humans to see what's wrong with it if you're not trained to sort of pay attention to it. But there is a reason that a computer would be unhappy with you, and it's this kind of fine print. You tried to use an identity, but the numbers themselves were not well defined at this step, and then there are all kinds of false and paradoxical things you can say by accident when you don't pay attention to that sort of thing. So that was the first one that's a little bit tricky, and the next two, well, that's just with multiplication, and then with division, there's some other issues you might want to think about. So you might want to attempt D or E. You might want to pause it, give it a shot. I know that I'm running a little bit long on time, so I'm gonna. So if you want to just keep going, I can kind of understand that. But let me just show you what happens for part D. So coming up next is part D. So what are all the things that could possibly go wrong here? So it's almost the same thing, but now we're dividing by square root of x minus 3. So this is f divided by g of x is equal to f of x divided by g of x. That's not the hard part. The domain part is probably the hard part. So again, we have this number line. So again, we have -3 and +3 as places where stuff happens. Again, these are bad because if x is equal to exactly -3, well, you're taking square root of a negative, square root of a negative. If x is exactly 3, well, what do we have? We have square root of 0 divided by, the numerator is, square root of 6 divided by square root of 0. Now, it's not times anymore. Now it's divided by square root of x minus 3. So we're dividing by 0, which is that particular point is for part C, 3 was okay. 3 was in the domain. But now 3 is not in the domain, but 4 is going to be okay. So we've got square root of, we try to evaluate the function, we get square root of 7 divided by square root of 1, which is just the square root of 7. So we're not in the domain, not in the domain. If x is anything bigger than 3, but not including 3, then we're sort of good to go. We know that square root of 0 is bad, dividing by exactly 0 is, yes, dividing by 0 is bad, taking the square root of a negative is bad, but x is strictly bigger than 3 are totally fine. So for this one, for part C, it was different. Remember the domain was including 3 going all the way out to infinity. And okay, now you've seen one of these. This one's going to be a little bit different. So just do it from scratch. Don't try to jump directly to the answer. Just sort of write it all down. Take it one step at a time. Just look at, you know, these 2 points are going to be the kind of the boundary points where interesting things happen, and then you take sample points in between, because you know square root of positive or negative or 0, when the inside of 0 is right at the boundary point where something interesting is going to happen. But then that was part D. So now try to do it, except the numerator and the denominator are opposite. So that this is D, so you can pause, and then now I think we're doing E now. So if it's E, we've got this situation. And all right, we know it's the same number line, but where do we draw the lines here? So what do we get? So g divided by f of x, the square root of x plus 3 is in the denominator. We can't take the square root of a negative. Well, we can't divide by 0, and we can't take the square root of a negative. So what do we have? We have square root of minus 6. This is bad for 2 reasons at the same time. So it's an imaginary number divided by 0, which is, it's not a real number, and then it's not anything at all. We're trying to divide by 0 on top of that. So that's really, really bad. But we can't plug in 0 either, because we have, still the numerator is imaginary. The denominator is square root of 3, but that's also bad. This one, it's the other, now this one is different. So when we get to this one, well, these two are flipped. So what happens at 3? We try to evaluate this function at exactly 3. Well, the numerator is 0. And then if you have 0 and then you divide it between 8 people, then well, sure, everybody gets nothing. That's no problem. I can give everybody in the world $0. Doesn't change, doesn't hurt me at all. Doesn't cost me anything. I just did it right now. So 0 split between 1,000 people or whatever. Or divided between square root of 6 people, whatever. It's still 0, so that number belongs to the domain, because the function g over f makes perfect sense. So part D, we had an open inner bracket at 3, but this problem, okay, so now I didn't erase the answer from last time, so now it's different. And that's sort of it. That's like almost everything is, I believe there's one where I gave you a negative exponent, so you might have to worry about double fractions. So yeah, that's something you'll have to be careful about. Do I want to give you a warning about that? Yeah, let me do just one example. I won't set it up in detail, but I want to show you an example of that kind of problem. So this is not exactly the same as the problem on the homework, but the kind of issue that we're going to see here is basically the same issue. So let's, I just want to do a big double fraction that's kind of, I don't know, so something like that. I don't want to go too crazy. And if that's exactly the function, then the trouble with simplifying it right away is that in order to simplify it, you have to make some assumptions about everything being in the domain. So let me use colors here. So we've got little denominators. That can be a problem. I guess these parentheses, if I have big parentheses, I don't need, those little parentheses aren't really doing much. But okay, so there's the little denominators. That could be equal to 0. That could pose a problem for the domain. And we've also got a big denominator. Which could be equal to 0. And that essentially is going to be the x minus 1 that's equal to 0. So, so the little denominators. So we've got a big fraction, but we've got fractions within fractions. So these little sub-fractions. So the little denominator equals 0 means that x equals minus 1, x equals 3. Big denominator equals 0 means that x minus 1 over x minus 3 is equal to 0. Well, this happens, you could multiply both sides by x minus 3 here. The only way the whole thing can be 0 is if the numerator is 0. Which is x equals 1. So there's 3 different places. The big denominator can be 0 because x minus 1 is 0, or the little denominators could be 0 as well. And even if these were both x plus 1 and even if they were to cancel after you simplify, well, the original expression had you dividing something by 0, which was not allowed, which is what's really important. So whether it's f or if it's f divided by g is the kind of situation where this is likely to come up. And then whether it's a denominator or if it's a negative power, you might see this in this other form. If the function were given this way, it means exactly the same thing. If it's given with negative exponents, it means the same thing. This is just a different notation. Dividing is the same thing as multiplying by the negative first power. Well, okay, so we've got it all written down here. We've got negative 1 is bad. Let's make sure we get them in the right order. 1 and then 3 on a number line. So bad, bad, bad. Everything else is good. Our function is well defined here, here, and here, but at none of these 3 points, but it's good everywhere else. So domain minus infinity to -1, union -1 to 1, union, kind of a run-on sentence, 1 to 3, union 3 to infinity. So I think this one, there's a little bit more going on here, but I wanted to give you kind of, it's not, in this class, it's not going to be any worse than this. I think that's kind of, as far as domain goes, I've given you just about one of everything that you might see in a class like this. And I think in college algebra, there are a few more that they might throw at you, but this, not college algebra, but pre-calculus. In pre-calculus, there are a couple more algebra tricks for dealing with a couple more situations, but I think we've covered most everything you're going to see here. So I hope that helps. I think at this point you should have enough to be able to do homework number 3. And then we'll keep going. Sometime later this week I'll post homework assignment number 4 and some more lectures to get you started with that stuff. Hope you had a nice holiday. It's nice that the uploads are finally processing. We got to play catch up here a little bit. I guess just keep on top of the announcements. I think we're pretty close to staying on schedule, but I'll take another look at some due dates and I'll make a decision about that. But we do need to keep moving. Homework 2 at the very least, you should be able to do it pretty soon, unless for some reason one or two, or a few of you still don't have your book. You can let me know about that, and we'll see. But I think most of you should be. Hopefully you all have your books by now, and homework number 2 is hopefully that there won't be any problem with that. But all right, that's it.